Hi everyone. So today we're doing differential equations. As I've written in the little task, this is one of the more difficult topics. The actual solving isn't too bad, but when we come on to forming differential equations, it does get quite tricky. So what I'd like you to do is start off as usual by having a go at the starter. So pause the video here, or obviously if you're on the PowerPoint, you'll just look at them. So pause the video, have a go, and I'll carry on talking in a minute. Okay, cool. So, yeah, I'll just show you the answers. I'll talk through them slightly. So, this first one, it does give you a substitution, so you are expected to use that substitution. If this was given to you in an exam and you didn't use the substitution, unfortunately, you would only be able to get the maximum of, let's say, 2 marks out of 5-ish. But if you notice, this question you could have actually used reverse chain rule. Okay, so if you use the substitution, you differentiate it, that gives you du by dx is 8x. You substitute all of that into your equation, well, your integral, and then you integrate it normally. So that one's pretty straightforward. This one, spotting what to do in the first place is probably the difficult bit. As you can see, it's a product of two things. Okay, product meaning multiplied. So when you've got a product like this, you need to use integration by parts. Okay. Now the formula for by parts is in your formula booklet. It's like this. Okay, so you need to pick whichever one is u and whichever one is dv by dx. In the lesson of by parts, I said to you that u is the one that you're differentiating. Now, whenever you have a natural log has to be the thing that you differentiate. Okay, so the thing that you differentiate is the natural log. Now here they've just straight up put u equals 2 natural log of x. You could have written to start with u equals natural log of x squared. However, using your laws of logs, you can bring the 2 down to be in front of the natural log. Okay, then the rest of that question is pretty straightforward. You just substitute it into the formula and there's your answer. Now the last one, all of the method of partial fractions has been skipped. It basically just gives you the answer. So I don't see the point in talking through the partial fractions really. You've done it many times in the past. So do the partial fractions, substitute those values back in. So you get 2 over 3x plus 2 plus 1 over x minus 1. Now if you integrate this, the bottom doesn't have an overall power, so it becomes natural log. The 2 stays at the front and you divide by its differential of 3. Same idea for this, doesn't have an overall power on the bottom, so you have a natural log, divide by the differential of the brackets, which is 1, so you just get natural log of x minus 1. Then remember you're integrating, so you need to put the plus c on the end. Okay, now I know I spoke very quickly for that, but that's because of the starter. If at any point you want to look back, make sure you just, it's not really rewinding, but go back in the video. Okay, so on with the actual lesson. Differential equations. Now, the name describes it. As you'd expect, the name does describe it. Differential. So if you find the differential of something, let's say you start with y, the differential of y with respect to x most of the time would be dy by dx. Okay, so a differential equation is an equation which just includes these differentials. Okay, now these differential equations, they will have these differentials mixed with y's and x's. You might have it in terms of different letters, so you might have t and you differentiate in t with respect to x. So you could have an equation that includes both t's, dt by dx's and x's. You could have all sorts. Okay. The main point though is that they do include this differential. Now, this lesson we're going to focus on solving. Next lesson we're going to be focusing on forming and then solving. So this lesson is actually really important because next lesson heavily depends on this. Now, to solve these equations, we need to use a method called separation of variables. Okay, so separation of variables. The name of it is not very important, however, I remember it just because it actually describes what to do. You separate the variables. So this question we start with dy by dx is equal to xy plus y. Now, the name, separation of variables, we want to separate the y's from the x's. We want all y's on the left, all x's on the right. Now, you might think straight away, oh, this y, I'm just going to take it to the other side to separate it from the x. Now, it's the right type of idea, but if you actually do that, so I'm going to write it, dy by dx minus y equals xy. Now, this isn't correct because you have this dx on the left. All of the x's need to be on the one side, all of the y's need to be on the other. This dx is included with the x's. Okay, this dx needs to be on the right hand side, not on the left. Now if we multiply up by this dx, we still have it on the left hand side. So we can't have numerous terms on the one side. Okay, we can't have different terms. We need to keep them all together. Now, there's a certain way you need to do this. Once you've got practice, you'll just realise that it's pretty straightforward. Keep the y's together. Here, if we factorise out the y, we have a single y for which we can now divide to the other side. Okay? Now all of the y's are on the left, however this dx is still on the left, we need it with the other x's, so 1 over y dy equals x plus 1 multiplied by dx. Okay, so notice how I haven't added or subtracted a thing. Okay, up here I tried to subtract the y, didn't I? Never add or subtract. Okay, unless if you have a term on the left hand side which needs to go over to the right anyway, I would always avoid adding or subtracting. I tend to stick to factorising and multiplying and dividing. Now, here we've separated the variables. Like you can square both sides of an equation, like you can square root, like you can cube, like you can just times both sides by 2 if you want, you can integrate both sides of an equation as long as you have these dy's and these dx's. So now we have two integrals that we need to work out. The integral of 1 over y is natural log of y. The integral of x plus 1 is a half x squared plus x, and we'll have a plus c. Now, like before, like with integration by parts, we do not need two constants of integration. Here we could have put plus c, here we could have put plus k or something. However, what we can do is just include the one constant, and then that accounts for both integrals. Now here, we need to get it as y equals, okay? A solution is always y equals, so raise both sides to the power of e, and there is a general solution. Now you could give that as an answer. You could, and you wouldn't lose any marks. However, I don't like the fact that this plus c is in the power. Now, if you use your laws of powers and that sort of idea, laws of indices, you can separate that one bit of the power from the rest. Okay, so we've got e to the half x squared plus x times e to the c. Now, e to the c is just a constant, isn't it? E to anything, e to the power of 2 is a number, e to the power of 7 is a number, e to the power of c, because c is a number, this is just a number. So what I'm going to do is let e to the c equal a. I don't like the fact I've just got a power on a constant, wrong way around, constant on a power. So I'm going to get rid of the power. I'm just going to let it equal a. Now here, e to the c is just a, so replace e to the c with a, and we get something that looks slightly nicer. I'm going to say slightly because obviously it's still a power and stuff. However, that is now our answer. Okay, so overall we need to separate the variables. So get all of the y's to the left hand side, get all of the x's to the right. That includes the dy and the dx. Then once you've done that, you need to integrate both sides and try to get y equals. Okay, and a little recap at the start. Here, do not add or subtract, only use factorising, expanding brackets, multiplying and dividing. Okay, and there is a nicer written solution if you didn't like my writing. Pause the video if you want to see it. I'm going to carry on now. Okie dokie. So, another example. Here, we've got a mixture of x's. So we've got an x on the left, we've got y's on the right, and we've got the dy by dx. So it is a differential equation. It's a mixture of y's, x's, and a differential. So we need to try and solve it. So separate the variables. I always try to get the x on the right, because when you multiply this dx up, the dx will be on the right. So the tan needs to come to the left, the 1 plus x squared needs to go to the right. So if you divide by the tan, that goes to the left. And I'm going to divide by the 1 plus x squared. Remember, because it's in brackets, 1 plus x squared is multiplied by dy by dx. So divide by the 1 plus x squared. So it's x all over 1 plus x squared. Okay, but remember, this dx is still on the left. So multiply over by the dx. And now all y's are on the left, all x's on the right, so now we can integrate both sides. Okay? Now, at this stage, the right hand side looks like something I could integrate. Okay? The bottom doesn't have an overall power, so it's going to be a natural log. The top looks relatively similar to the differential of the bottom, so we could use the reverse chain rule. The left hand side, 1 over tan y. Now, this doesn't look very nice. This is where I would get my formula booklet out and start looking at my integrals. There isn't a formula for 1 over tan y. However, there is a formula for cot y. And since 1 over tan y is just cot y, I'm going to rewrite it as it. Now, cot y, if you look in your formula booklet, cot y is just natural log of sine y. Now the right hand side, I'm going to consider the answer natural log of 1 plus x squared. Now if we differentiate this, we'd get dy by dx is 1 over 1 plus x squared multiplied by the differential of this thing inside the natural log, 2x. Now compare it to the thing we're actually aiming for. It's 2 times as large, isn't it? So the actual integral is going to be half the size of the thing that we considered. Okay, and then remember our plus c. Now, we have done all of the integration, we've done the separation of variables, now we need to just get it in a nice form. Notice how we've got a natural log, and a c. This constant isn't very nice, because we could try and combine these natural logs, couldn't we? But this c is messing things up. Now, when you're doing these sort of questions, you need to start thinking about your constants a little bit more than usual. Here, I've written a c. However, what might be nicer is if we used a constant natural log of a. Okay? So instead of c, I'm going to use natural log of a. So I'm going to rewrite all of this. Here, I'm going to use a law of logs. I'm going to bring the half as a power. Oh, that's not meant to be curved. That's meant to be a modulus sign. Okay, so I've brought the half into as a power, and then the natural log of a I'm just going to write instead of the c. Now, we've got natural logs all throughout, so I'm going to bring these two together on the right hand side. So the a I'm going to bring into the natural log with the 1 plus x squared to the power of a half. Okay, using laws of logs. And now both sides are natural logs, so people usually describe it as cancelling out the logs. You're not doing that. That's not the right way to say it. You're raising both sides to the power of e. Okay, now the e and the natural log cancel out, and you're left with sine of y equals a brackets 1 plus x squared to the power of a half. Okay, now we're almost there, aren't we? We've literally got a single step. We want y by itself, so arc sine both sides. This half I'm just going to rewrite it as a square root. And there is my answer. Okay? Now hopefully you understand that question. I'm going to go over it very quickly again. Separate the variables, bring all y's to the left, x's to the right. Here we didn't know the integral of 1 over tan y, so rewrite it as cot. Integrate both sides. Then here, so the c was the thing that made this question slightly different. Because we've got natural logs all throughout, I'm going to use a natural log of a. So natural log of a constant is still a constant instead of just a constant by itself, so that we can rewrite our equation to be something that's slightly nicer. Okay. Again, there's a nicer written version, so if you want to have a look, go ahead, but I'm carrying on, so pause the video if you want to look. Now, I'm pretty certain that this is the last example, so differential equations so far, what we've done is just used a differential equation, solved it, and written a solution with a constant in our solution, so a c or an a. What we can be given sometimes are what's called boundary conditions. Boundary conditions are values that we substitute in to get rid of the constant of integration at the end. Okay, so boundary conditions, if anything, they're no more difficult, it's just an extra step at the end. It just gets rid of that constant. So, this question, dy by dx equals minus 3 brackets y minus 2 all over that bottom. So, start off by separating variables as always, because this is clearly a differential equation. It's a mixture of x's, y's and dy by dx. So, the x's, they are on the bottom of the fraction, so you could multiply up to the left. However, remember what I said on the last example. When we multiply this dx up, it's going to be on the right. So all of our x's need to be on the right, so they need to stay on the bottom of the fraction. So that right hand side, the 2x plus 1 and the x plus 2, need to remain there. The y minus 2, on the other hand, isn't staying there because it isn't an x, is it? So the y minus 2, divide it over to the other side. Okay, now I'm going to do it all in one step. The dy stays on the left, the dx goes over to the right, and we want to integrate both sides. Okay, so I've brought the y minus 2 to the left, I've brought the dx to the right, and I've integrated both sides. Well, I've written the integration signs. Now, the left-hand side, we know that that's going to be a natural log. It's a pretty straightforward thing. This right-hand side, this is where you need to start thinking about your integration methods. This, it's got a product of 2 brackets on the bottom of the fraction. Therefore, we're going to need to use partial fractions. So we're going to write this in the form... Oh, give me a sec, let me just write this out properly. We're going to write it in the form a over 2x plus 1 plus b over x plus 2. Now, I'll do this very quickly. So, multiply up both sides by the fraction on the left. Okay, now you should know how to do this already. So I'm going to let x equal minus a half. That means that we're going to get 3 over 2a equals 3, which means that a equals 2. I'm going to let x equal minus 2, which means that we're going to get 3 equals minus 2 into here, minus 3b. So b equals minus 1. So b is minus 1, a is 2. So here we've got the integral of y minus 2 on the bottom of the fraction equals, I'm going to bring this minus out because it's going to make things a little bit complicated in a minute. We've got a, so 2 over 2x plus 1, and then b is a minus 1, so I'm going to put the minus in between the fractions, and it's 1 over x plus 2. Okay? Now, I could bring this minus back in, but I honestly don't see the point at the moment. So the left-hand side is going to be natural log of y minus 2, divide by its differential of 1, so it stays the same. I'm going to put the minus on the outside, actually, yeah, I'm going to stick the minus on the outside, because why not? Then on the inside, we've got natural log of 2x plus 1, with a 2 at the front, but we need to divide by the differential of the bracket, so we divide by 2. So these 2's cancel, don't they? Then this second thing, it's going to be a natural log of x plus 2, divide by its differential, which is 1, so it doesn't do anything. Now again here, we've got natural logs throughout, so instead of c, I'm going to straight away use natural log of a. Okay? Here, instead of using c when I integrate, I'm going to use natural log because all of this is just going to sort of combine together in a bit. So, now here we can combine this straight away, can't we? So natural log of y minus 2 equals the minus of, we've got a and 2x plus 1 multiplied with this x plus 2 on the bottom. So natural log of a 2x plus 1 all over x plus 2. Okay? Now this minus, because it's on the outside of the natural log, it becomes a power. This minus, it becomes a minus 1, doesn't it? But a minus 1 just flips the fraction. So I'm going to do that straight away without actually writing anything in between. And there you go. Okay, so this minus, I've brought it into the natural log. Because it's a minus 1, okay, you could put the 1 there if you want. Because it's a minus 1, a power of minus 1 flips a fraction, so I've flipped the fraction without actually writing the minus 1 straight away. Now here, We've got natural logs on both sides, so as I said on the previous example, we can raise both sides to the power of e, so we get y minus 2 equals x plus 2 all over a bracket 2x plus 1. Okay? Now, we can bring this minus 2 over straight away, can't we? And there we go. Now, you'd think we're finished, but it's got this constant, hasn't it? So, x equals 1, y equals 4. The main purpose of this question is to get rid of the a. So, we're going to substitute in x equals 1, y equals 4. So, when x equals 1 and y equals 4, it's going to be 4 equals 2 plus 1 plus 2 all over a brackets x is 1, so times by 2 plus 1. So rearrange all of this, we're going to get 2 equals 3 over 3a. That's right, isn't it? Yeah. And whoops, I've accidentally gone forwards. Yeah, you can find out the value of a. I think it should have been 2, and there you go. Yeah, put 2 back into it and you can work it out. Here's a nicer version of the answer. Down here, they've done exactly the same as us. Here, they've just got the k on the top. Doesn't make a difference. Then what they've done is actually used algebraic division to actually simplify the fraction. You don't need to do that, okay, you don't need to, but what they've done is used algebraic division to get rid of the x on the top and then combined the overall whole number from the top heavy fraction with the 2 to get 3. Okay, so what I'd like you to do now is have a go at this exam question. So pause the video here. You can come back to this after some practice from the actual exercise if you'd like. That is entirely up to you, but this is an exam question for you to try. I'm going to show you the answer to this exam question now, so if you don't want to see it yet, skip over this next little bit of answer. Okay, so there's the answer for the exam question, and now there is a very quick summary. Pause it if you want to read it, but I'm just going to skip over it because you can read it yourself if you want. Those are the questions from the exercise that I'd like you to try. Okay, so that's it for this hour lesson. You'll have a different lesson for forming differential equations. So pause the video, have a go at those questions please, and submit your answers onto the classroom for me to mark and annotate please. Okay.